am so excited to be here. This is my first time in Denmark. I had wanted to come last year, and then I got sick right beforehand, and so my dear friend Abby Bankser came instead, which is quite a treat. I love getting to hear Abby speak, but I'm really excited that I could make it this year. For those of you who don't know me, my name is Charity. I am a co-founder of Honeycomb.io, co-author of Database Reliability Engineering and Observability Engineering. Anybody here happen to have a copy of the Observability Engineering book? You should see me after class, because I brought these sheets of stickers where you can decorate the little wolfie dog with like Hello Kitty like ears and bows and stuff. So anyway, all right, down to business. Every company is now a technology company, as Mark Andreessen famously said. Software is eating the world. What this means, well, it means a lot of things, but one of the things that it means is that things like engineering efficiency and productivity and how well we do our jobs are no longer niche concerns. I really loved that lightning talk by the guy from Microsoft. Are you in here? So good. So good. I wrote down a bunch of notes. I can't wait to show my co-founder the recording. We have been talking lately about how observability is, explaining technology in the language of the business. I'm old enough that when I was coming up through the ranks, it was like not very cool to care about the business. It was all about tech for the sake of tech. And there are a lot of reasons to be depressed in the world right now, but one of the reasons to not be depressed is I think that we're really starting to realize that tech is in the service of greater things, right? So another consequence of this is, whenever I'm giving someone career advice, I tell them the best thing you can do for your career is find a high-performing team and get on it. High-performing teams are ones that get to spend most of their time working on interesting, novel problems that move the business materially forward. Those are numbers from the DORA report. Not this year's, I should update them, but part of why this matters is that individuals don't own software. Teams own software. What do we call an individual who owns a service? We call them a single point of failure, right? Teams own software. The team is the smallest viable unit of software ownership. And how do we build high-performing teams? Well, obviously, it's by hiring all the ex-Googlers and ex-Facebook people we can get our hands on. No, this is not how we build high-performing teams. And in fact, the question of how well does your team perform is not the same question as how good are you at engineering. Being good at data structures and algorithms is a necessary precursor, but it doesn't actually mean that you're great at developing. Because your ability to ship code swiftly and safely actually has less to do with what's up here and everything to do with the socio-technical system that you exist in. You can be the best engineer in the world. You could be Kent Beck. If you join a team that takes 2 months to ship a single line of code to production, how long is it going to take you? It's going to take you 2 months, because the socio-technical system is what defines how quickly, how swiftly, how reliably we can ship our code. Which is why I think if technical leaders have one job, it's this. It's constructing and tightening the feedback loops at the heart of your system. Feedback loops at the heart of your system. And when I say technical leaders, I don't just mean managers and directors and VPs, right? If you are you're a baby junior engineer, you're not a technical leader yet. Your job is to become a senior engineer. Once you're a senior engineer, you are a technical leader, or you should be, right? You are someone who is helping. Engineering is not a craft for followers. Engineering is a craft for people who care about building things and fixing things and understanding things and making them better. When I think of modern software development practices, I think about things like this. Engineers owning their code in production, which includes being on call, but is not synonymous with being on call. Practicing observability-driven development, where you're writing your code, you instrument as you go, you ship your code, and you look at your code through the lens of the instrumentation you just wrote, and you ask yourself, is it doing what I expect it to do, and does anything else look weird? Testing in production. For those of you who can't see my shirt, it says, test in prod or live a lie. I also have stickers that say that. People ask me like, oh, I can't sell my manager on letting us test in production. How do I do this? Number one trick, don't use the words test in production. Call it validating in your code in reality or something like that. But like, the truth is, if you have code, you test it in production. The only question is whether or not you admit it. And the first step towards doing it well is admitting it and investing in the tooling around it so you can do it safely instead of just like by the seat of your pants because you don't have any other options. Separating deploys from releases using feature flags, continuous deployment. And what all these things have in common, they're all about fast feedback loops. They're all about getting your code out in front of users as quickly as possible after you've written it. Because when it comes to software, speed is safety. As embodied human beings, we have this tendency when we get scared or anxious to freeze up and slow down. But that's not good with software. Software is more like ice skating or riding a bicycle, where if you want to do it safely, you have to have speed and regularity and consistency. Getting code into production fast is that kind of key feedback loop that everything else proceeds from. Because the cost of finding and fixing bugs goes up exponentially from the moment you write them. You type a bug, you backspace, good for you. That's as fast as you can fix it. You find it with your tests, great. Your next best shot of finding the bug is right after you've shipped it in production. Because right after you've shipped it, you've got all of the context right here. You know what you built, why you built it, what you tried that worked, what you tried that didn't work, what the functions are called, what API is it called. Everything's right up here. And how long does it last? Not very long. I have a bad memory, but even still, like, I feel like hours, maybe a couple days tops. It definitely, for me at least, it does not survive paging in and out another project, right? So looking at your code in production is how you close that loop, that feedback loop of here's what I'm trying to do, here's what it's doing. If you don't find it, it's probably not going to be you that finds the bug. It's probably going to be one of your customers or your users. Maybe another engineer. Who's going to fix it? Probably not you. Some other poor sap, weeks, months, years into the future. It's just going to recede into the background of, oh, this is just part of, this is normal, right? God, there are so many bugs right now that we just think of as normal. Distributed systems all exist in the stage of like permanent degradation. Like there's so many things broken in your system right now. And this is a good thing. This is fine. You sleep great at night. For the most part, this is actually a phenomenal accomplishment that our systems can be resilient to so many things. Your ability to move swiftly with confidence is grounded in the quality of your observability. What does this even mean these days? That's a great question. So when Christina and I started Honeycomb back in 2016, observability was not a term that was in use in the industry. And we were trying to figure out how to talk about what we were building. And that was when I first Googled the term. And I read this definition on Wikipedia. So observability traditionally comes from control system theory, where it's the mathematical dual of controllability. And it means how well can you understand the inner state of your system just by observing its outputs. And I read that and I just went, like, I had one of those moments where you're just like, oh my God, the world stops for a minute and you're just like processing it. It was so cool. So after that, we spent a couple years trying to, we made this laundry list of, well, this is what it is, and this is how it's different from monitoring, blah, blah, blah. And 2019, Peter Borgen came out with this definition that observability has 3 pillars: metrics, logs, and traces. And a lot of vendors really glommed onto that. They coincidentally had at least 3 products to sell: metrics, logs, and tracing products. Got added to the Magic Quadrant, blah, blah, blah. So at this point, there are so many definitions of observability out there that I've kind of declared bankruptcy. And I think of it this way. I think that observability is a property of complex systems, just like reliability or performance or scalability, which I like because it puts the emphasis on the system instead of the tooling. But I also don't like because then it sort of like leaves us back with the whole question we were trying to figure out in 2016, which is like, how do we sort of differentiate and distinguish the sort of modern generation of tools that we're trying to build versus the generation of metrics, logs, and traces, which is why in the last few months I've started thinking about it in terms of versions. Now, semantic versioning tells us what? That whenever you're doing a major version bump, it's for breaking backwards incompatible changes, right? I think that that's what we see here. The 1.0 tool universe is one that's grounded in metrics, logs, and traces. You know, you're capturing, for every request that enters your system, it's actually more than 3, right? You're probably capturing some in structured logs, some are in unstructured logs, some are in metrics, some are in traces, but then you've also got your APM tool, you've got your RUM tool, you've got your profiling tools, you've got your product analytics tools, you've got your, the multiplier can get quite large sometimes. And what connects all those tools? Nothing. Not much. Usually it's you, the engineer, who's sitting in the middle going, well, that shape looks like that shape. Probably they're the same thing. Or copy pasting, well, let's take this log, the request ID from the log tool, paste it into the tracing tool, and cross our fingers that we happen to sample this one in. There's a lot of guessing, there's a lot of jumping around. So how is this different from 2.0? I think that we're seeing an emerging generation of tools with a single source of truth. Arbitrarily wide, structured log events. These are also sometimes called canonical logs. You could also visualize them over time as a trace if you've added span IDs and trace IDs. But because you're packaging all that context in, you can derive metrics, you can derive SLOs, you can derive your dashboards, you can slice and dice on any of those dimensions. You can zoom in, you can zoom out. The reason the 1.0 requires you to capture it so many different times is because it's not collecting enough context for you to be able to connect the dots from one to the other. And the magic with the 2.0 model, which I think Honeycomb was the pioneer, but we're seeing people start to do this using ClickHouse-based tools. We're seeing people using it using DuckDB. A lot of other columnar databases are now available. I think there are a lot of folks out there who are maybe not using this terminology, but I think it so clearly is the future. So that's kind of what I want to talk about here is the old generation of tools and the new generation, why it matters, how to recognize them, how to build them, and so forth. I'm just quick overview. These slides are posted online. I'm not going to go into this deeply here because we're going to go into each one of these things, but like at a high level, that's your 1.0 and that's your 2.0. Now, when we started trying to define observability back 8-ish years ago, we ended up with this laundry list, right? We were like, so there's monitoring the old way and observability is a new way, and you only have observability if you have high cardinality, high dimensionality, arbitrarily wide structured log events, the ability to trace, all this stuff, right? Which, in retrospect, is very obvious why this didn't take off, because who has time to memorize this shit? Nobody. I think it's much easier to think of it this way. Either you have many tools in a 1.0 world, or you have one source of truth in a 2.0 world. So let's start first by talking about how the data gets stored. I think most of this is pretty self-explanatory, right? You've got your 1.0 world where every single one of them, they're deciding what format, they're deciding basically what questions you're going to be able to ask in the future at right time. And one of the beautiful things about Observability 2.0 is that you're declaring bankruptcy. You're like, I'm never going to be able to predict in advance all the questions I'm going to need to ask. So I'm going to store these raw events so that I can make those decisions at read time aggregation instead of write time aggregation. Ultimately, there are only really 3 types of telemetry data. There's the metric, unstructured logs, and structured logs. And if you look at what people are using out in the industry, like 80% of all tools are built on top of the metric. RUM tools are built on top of metrics to understand browsers and user sessions. APM tools are built on top of metrics to understand APM performance or application performance. And the reason for this is that metrics are, I have that sticker too. They're tiny, right? A metric is not a data structure, it's a number. A metric is a number with some tags appended, and you store it in a time series database. You store absolutely no connective tissue. They don't have, you can't do high cardinality, there's no context. They're extremely limited. And I have been talking shit about metrics for years, but I want to make it clear that it's not because I hate them. And it's not because they don't have any use cases. They do. There are some use cases that metrics are appropriate for. Anytime that you're trying to summarize a vast amount of data, metrics are your tool. Like, that's what they're for. In fact, going all the way back to how many of you are old enough to remember RD tools? Yes, a couple people. So RD tools were the original metrics tool where, you'd capture your data and then it would age out over time. You would retain the shape of it, but you would say like, okay, I'm going to spend 5 megabytes on this. And then it would be 5 megabytes forever, even as the data aged out. So metrics are the right tool for summarizing vast quantities of data, aggregating them so that they can cheaply age out. They're also, at a certain scale, they're the only thing that you can use, although that scale is typically a lot larger than most people think that they are. Metrics will let you do things like counters that are harder to do with structured data. And they're pretty good for infrastructure. What they are not good at is helping you introspect and ask questions and iterate on your software. Which is why, to understand our systems and our software, we need to turn to logs. Even unstructured logs are more powerful than metrics because they preserve some context, but they tend to be very messy and expensive. You really kind of have to know what you're looking for in order to find it. The only thing you can really do is string search, which gets slow. Next, let's look at who uses this and how. In Observability 1.0, I think one of the most interesting implications of this is that it's historically been an ops job, right? Software engineers would write their code and then heave it over the wall for ops teams to instrument it, monitor it, and understand it. Now, I think the idea that half of your engineers will write your code and the other half will understand your code has always been a pretty flawed proposition. But Observability 1.0 has always been very much about MTTR, MTTD, and errors, and downtime, and crashes. In other words, it's about how you operate your code. And Observability 2.0, it includes those things, but Observability 2.0 is much more about how you develop your code. It's about hooking up those fast feedback loops. It's about more than just errors and bugs and downtime and outages. It's about understanding what you've built. It's about understanding how users are interacting with what you've built. It's about understanding what they're doing that you'd never thought that they would do. What are they leaning into? What are they getting creative about and how they use it? There's so much about understanding our software in production that goes beyond just, oh, it's broken, I need to understand it. I think we should want to understand it, not just when it's paging us in the middle of the night. You don't know what good looks like if you're only looking at your software when it's broken. Observability 1.0 is how you operate your code, and 2.0 is about how you develop your code. How you interact with your code in production. So in 1.0 land, we would often deploy our code and wait to get paged, right? Software engineers historically have this idea that they can merge their code and then their job is done. If the tests pass, my job is done, right? No, definitely not. Your job is not done until you know that it's working in production, which means closing that loop by looking at it. So one of the interesting things that I think is that, so again, I'm old enough to remember that we used to take pride in not having to look at our code all day. We used to take pride in the idea that your code would let you know when you need to go look at it. And this makes sense when you think about what we were reacting to, because we were reacting to the days of the NOC, right? The Network Operations Center, where you had people, poor saps, sitting in data centers all day just staring at walls of dashboards, right? And we were like, well, that sucks. We should be able to automate this. Nobody should have to sit there looking at their telemetry all day. And so we went all the way over to the side of, you shouldn't have to look at your dashboards or your code unless it's paging you. And this, I think, is flawed, because part of this whole, putting developers on call for their code, making engineers support their code in production, part of the agreement that we make is that it's not just, oh, we've suffered for 20 years and it's your turn to suffer now too. That's not the goal of it, right? The idea is that this is actually the only way that we can make software better, is by closing and compressing those feedback loops so that the person who has the context about what they're building and why they've built it in their head is looking at it in production and asking themselves, is it doing what I expect? Is anything else good? You can't break that feedback loop up into two different people, right? That has to be in one brain. But part of the contract of making it so that people support their own code in production is, it was never a good idea to just be like page bombing people, but now that developers are on call, it's really not okay, right? We need to make it so that you're not getting woken up unless users are in pain, right? You don't page people unless your SLOs are being violated. You don't try and predict, ooh, we think our users are about to be in pain, because you can't, right? You page someone and wake them up only when users are in pain, according to your SLOs. So we're raising the bar about what is going to alert us, which is a good thing. But most problems, most issues with your code are not going to rise to this level. Most of the problems in the code that you ship are going to be small ones. You're going to need to look for them. You're going to need to ask yourself, is it doing what I expect? Does anything else look weird? Which is why, and I actually don't think this is going to be like the best we can do indefinitely. I think that there's a lot of interesting stuff coming over the next couple years, but it's kind of chicken and egg. Until you have observability 2.0 type tooling, where you can slice and dice and compare, what exactly is different between this build ID and this build ID and this and this and this aspects. You can't do a better job while you're on observability 1.0, because all you have is aggregates and randoms. You can't slice and dice and compare. So it's a little chicken and eggy. And I think that we're going to get better at building tooling on top of observability 2.0, tools that will let us not have to close the loop quite so manually. But right now, this is the state of the art. This is the best we can get. The best that we can do is to close the loop by deploying our code and looking at it and asking ourselves, is it doing what I expected to do? Does anything else look weird? That's how we find problems before our users do. That's how we find problems before our customers do. How we debug. So one of the other really interesting ramifications of the 1.0 to 2.0 shift is that historically, the best debuggers have always been the people who have been there the longest. Always. There's always some guy who's been there forever, who's the debugger of last resort, and if nobody can figure it out, you're not going to. And I know this because I have always been this guy. I love being this guy. I love being the cranky old dude in the corner who's just like, yeah, I know because I built it, I love it. There's no better feeling than everything's on fire, nobody can figure it out, and you just look and you're like, it's Redis. I know. I know it doesn't say that anywhere, but trust me, it's Redis. And they go and they look and it's Redis. And they're like, oh my God, how did you do that? And you're just like, yeah. It's as close a feeling to God as I've ever experienced. It feels great. It's not really healthy. It's not really good for you or me or anyone else, right? But it's the best we've been able to do. And the reason it's been the best we've been able to do historically is because, back to what I said at the start about how you've got run, API, metrics, dashboards, logs, unstructured logs, structured logs, traces, profiling, and nothing connects them but the person in the middle who's, you have to fill in so many of the blanks with your own intuition, your knowledge of past outages, your knowledge of having been on call before and seeing something like that, the fact that you built the system. You lean so much on stuff that those connective bits don't exist in your tools. They exist here, right? So you get these demigods, people who've been there forever, who are the only ones who can figure it out. And for a long time, I just thought, well, that's just the way software is. That's just the way complex systems are. That's just the best we can do. But it's not. The reason we started Honeycomb was because, so I was engineering manager at Facebook back in 2014 or whatever, and the most junior person on my team started feeding some of our data sets into this Scuba, was a tool, which is not great tool, kind of ugly and hostile to users, but it did one thing. It was 2.0 shaped to let you slice and dice on high cardinality dimensions in real time. And little junior dude started finding things and fixing them faster than I could. It was a little bit humiliating. And up until that point, I had just been like, no, I built all of the Nagios and Ganglia and Graphite and Grafana. I built the stuff. I have my bookmarks. I know how to find everything. I'm the debugger of last resort. And then most junior people on my team start finding and fixing things faster than I could, and without all the knowledge I had up here. And I was like, oh, shit. There's something interesting there. So we started using it, right? And then we started Honeycomb. And so now I've seen it team after team after team, where once you start instrumenting your code and debugging it with 2.0 stuff, since that connective tissue exists in your tool, the best debuggers are not the people who've been there the longest. They're the people who are the most curious. The people who have a habit of checking up on their code after they deploy it. Is it doing what I expected it to do? Does anything else look weird? Because the data exists. You don't have to guess, and you don't have to have been there for 10 years. And I think that is so encouraging and heartening. It's depressing to join a team and know that you could never catch up and be the best. And while it feels really good to be, God once in a while, it also feels nice to be able to take vacations and go on your honeymoon without getting woken up at 3 a.m. The cost model, I'm not going to go into this super deeply because I've written a lot about this recently. I've got a couple of white papers up and stuff. But the cost model of 1.0 is what is driving a lot of people to adopt 2.0. Because while I would argue that 2.0 is easier, simpler, faster, cheaper, it's also different, right? And when it comes to developer tools, I think you can't tell someone, well, this tool is 30% better than what you've got. The cost of the change just isn't worth it. I think pretty much what you're offering them has to be an order of magnitude better or cheaper for it to be unquestionably worth the cost of changing. And a lot of people are running into this issue with the cost model of observability 1.0, where every request that enters your system, they have to pay for RUM and APM and logs and metrics and traces and profiling and all this stuff. And not only that, I think even worse is the cardinality thing. Now, cardinality, for those who aren't familiar, cardinality refers to the number of unique items in a set. So if you've got a collection of 100 million users, any unique ID is going to be the highest possible cardinality. Social security number, request ID, right? Low cardinality would be something with only a couple of values, like species equals human, cardinality of 1, right? Gender might have a cardinality of a few, right? Now, the biggest issue with metrics is that they don't support cardinality. And this is a problem because cardinality is the number one thing that helps you understand your system. The higher the cardinality, the more identifying the data is, and therefore the more quickly you can find and fix your problems. And the biggest problem with the cost model of the 1.0 world isn't actually that you have to pay again and again and again and again and again. It's you have to pay for the cardinality. I know entire world-class observability engineering teams that spend an outright majority of their time just trying to manage the trade-off between enough cardinality to understand their business, not so much that they go bankrupt. So they're just constantly deleting metrics and adding them, and deleting them and adding them, and it's absurd. It is insane. I did some envelope math. Again, this is all in the white paper. The cost of a custom metric for request.latency, for one metric, if you have 1,000 hosts, 5 methods, 20 handlers, 63 status codes. It costs $63,000 per month for a heat map for request-out latency, which is absurd. It's going to send all of us bankrupt. Now, of course, anyone who is familiar with metrics is going to go, well, actually, this is why we don't capture all 63 status code. This is why we bucket them into 100 and 200 and 300, which I get. There are so many hacks and workarounds and talks on how to have less cardinality. I swear, if we spent 1/10 as much of the energy as we invest into trying to have less cardinality into just using tools that let you have as much cardinality as you want, we would all be in so much better state. And I don't know how many times I have debugged some random-ass weird thing just because it had an unusual status code or a weird string in the response. It's actually really valuable data. I would never actually claim that good observability is cheap. It's not. For almost everyone, it's going to be the second largest bill after your cloud hosting bill. Somewhere around 10 to 15% is where people typically flatten. But I think the bigger problem is that with Observability 1.0 tools, as cost goes up, the value that you get out tends to go down. Search gets slower. Cardinality stuff takes tons of manual maintenance. Observability 2.0 isn't cheap, but the costs are predictable and aligned with engineering value. It's faster, cheaper, simpler. The way that people are doing it now is the hard way. I cannot emphasize that enough. It is so hard. We have learned to be so incredibly clever when it comes to trying to wring value out of metrics and unstructured logs. But what if we didn't have to work so hard? What if it was just data? Now, doing a jump from one tool to another is something that not a lot of people or teams have time to prioritize, which is cool. I get it. The bridge, like the one foot after another, the place that people should start is by looking for places they can stop investing into metrics-backed tools and start investing into their logs. I wrote a white paper, I think we just published it last week, concrete steps that you can take to widen your logs, issue fewer of them, ways that you can back it with, columnar databases, all this stuff. And it's not that metrics are useless. It's not. They have their place. But they are not equipped to help you do the interesting work of introspecting and understanding your systems. We build better systems by building software this way. We also become better engineers by building software this way. Instead of just eyeballing graphs, when we get into the habit of asking a question, asking another question, putting one foot in front of the other, following the trail of breadcrumbs. What we can do now, start moving towards Observability 2.0. Instrument your code using the principles of canonical logs. It's hard to overstate just how valuable this is. Make them wide. Wide, wide, wide. The wider your logs, the more context you're packing in. The more context you're preserving, the more your ability to identify outliers and weird correlations. This is why at Honeycomb, we only charge on number of events you send. You can make them as wide, I think up to the limit of the Linux files that can be open based on the kernel, because it is so valuable to have all that context. Add trace IDs and span IDs so that you can trace your code using the same events just by visualizing them over time instead of having to hop between tools and store the same data multiple times. Feed your data into columnar store to move away from a world where you have to define in advance which attributes you want to be able to index or search on efficiently. Use a storage engine that supports high cardinality. Adopt tools with an explorable interface. I've also ranted a lot about dashboards, which is probably something I should not have done or should stop doing. The problem is not dashboards. Dashboards absolutely have their place. The problem is static dashboards that don't allow you to interact with them, that don't allow you to ask, and then what, and then what, and then what? You want dynamic dashboards because they're better. What got us here won't get us there. We used to be able to reason about our architecture. That was the diagram of a system that I ran back in 2003. I think that's Linden Lab. That was Parses back in 2013. That's the US electrical grid. And that's really the kind of dynamic, unpredictable distributed system that we need to be designing for and building tooling for. You can't predict. A tree is going to fall over in the middle of Main Street in a small town in Ohio tomorrow. Can you predict where? No. Should you try? No, of course not. You should build your tooling so that wherever it falls over, wherever the electricity goes out, you can swiftly slice and dice and isolate it and find it and fix it. The complexity of our systems continues to skyrocket. And as we're looking forward to a future where AI-based tools are increasingly, part of our everyday lives, I think it's really important for us to emphasize this, that the next generation of systems is not going to be built by people who are burned out, sleeping under their desks, powering through. I'm old enough to remember in Silicon Valley when it was super cool to just be like tired and exhausted all the time, just like brute forcing it. That doesn't work. When what's valuable about your brain is being creative and emotionally engaged and interested in what you're doing, our systems become too complicated and too hard. The stuff that can be automated will be automated out of existence. Writing code is not the hard part. It's never been the hard part. The hard part of software has always been understanding it, maintaining it, scaling it, extending it, operating it, migrating it, refactoring it, instrumenting it, reasoning about it. We can no longer try and hold the model of the systems in our head and reason about it or intuit the solution or figure it out by reading lines of code. Those who try will lose. Our systems are increasingly emergent and unpredictable, and it can't be automated out of existence, and it can't be operated using a runbook. It really takes your full, embodied, creative self. I think that Observability 2.0 is here to help advance the craft of software engineering, making it faster and safer to bring change to the world. And I believe that the biggest obstacle between us and a better world is that we don't often believe one is possible, or we don't believe that it's for us, or we think it's only for ex-Googlers, ex-Facebook engineers. But the way people are doing it now is the hard way. There are better ways. Everybody deserves good tools. So in conclusion, we'll end in my very favorite graphic of all time. Are we too busy to improve? Yes, no? Thanks.